Okay, this is a video. In this video, we'll be looking into the methods by which we determine the rate of reaction. To start with, in this content, we'll be talking about product analysis. That's one way of analyzing the action mechanism. Next, presence of intermediate, followed by crossover experiment, then followed by isotope labeling, stereochemical evidence, and finally kinetic evidence. Suppose looking into this reaction. So this is the reactant, and this reaction, what happens? By looking the presence of bromine acting as a leaving group and hydroxyl group which may act as a nucleophile, one may commonly think that this would be the product. That is simple cyclization. How does cyclization happen? The lone pair of electron on top of this oxygen may attack the carbon, facilitating the departure of the bromine as a good leaving group, and cyclization happens. So this is the mechanism: attack of a nucleophile and consecutively departure of the leaving group, leading to a cyclized product, and after deprotonation you'll end up with the product. That's what one might obviously think, but there are other factors to be get considered, namely energy, ease of formation, distance between the bond and the molecules or groups are present in the molecules. All has to be taken into consideration before we predict the product. So realistically speaking, this is not the product that obtained. So if the ring process not happened, something else would have been formed. So how to propose the mechanism, or what are the dictating factors? That's what we'll be discussing now. So why do we talk about reaction mechanism? This is the one which tell you what are the molecular or atomic events that are happen while the reactant becoming something else, that is product. Actually, we know that there may be some bond breaking as well as there may be some bond making, such that we say that the final one as a product, and the whole process is called progress of reaction mechanism. What are the factors dictating it? There are two important parameters. One is the energy constraint, the another is how rapidly or ease of formation. So this is the factors that are dictating the progress of reaction. So in order to find out the molecular events, there are three important factors to be considered. Number one, whatever the mechanism that we propose, it should be energetically favorable. Number two, it should consistent with the experimental observation. And finally, the proposed mechanism should not be a very uh, a new one. Rather, it should be in line or which must be very close to that already known or familiar reactions. That's how we always generate reaction mechanism. So, if this is not the product that is obtained, then what do you think? It's better we go for product analysis, meaning let's the reaction being carried out under the given set of condition and let us get the product. Then once we obtain the product, that may give some inputs regarding the path which the product might form. Okay, so this is what might happen. So if this is not happen, what are the factors to be considered? Okay, so here this is the original reaction happen. Looking the reactant and comparing with the product, one thing is obvious. Here the OH as well as this phenyl group are anti to each other. Anti to each other. Number two, there is a migration because you see that the phenyl group is in the left tree, but here it is in the right hand side. So there is a migration as well as this alcohol become ketonic group. Okay, therefore this is a Bergman rearrangement. So in order to propose mechanism, it's better we find the what the product is and we consider the familiarity, which is an Bergman type of rearrangement, and of course always accompanied by the departure of a leaving group. That is, the OH should be turned into a good leaving group. Probably this reaction might carried out in presence of water, such that water would have been protonated over here, forming water, and it get departed easily, that facilitating the phenyl group which is trans to the opposite, which is trans to this group. So it's all already known factors. So that's how we should propose mechanism. So going for the mechanism in detail. So as I said earlier, water get protonated, now become water molecule or hydronium ion, which is a good leaving group, so it departs. Now this departure of leaving group facilitates the migrations of the group, any group for that matter. Here you have methyl group as well as phenyl group, but just because it is anti to that of your OH group, it is the phenyl that migrates. So migrates over here. That's what actually Berkman rearrangement. So once this migration happens, so it's a closer mechanism. So water alcohol get protonated, forming water, becoming a good leaving group, and it departs. Bond breaking, and there is a migration. It is accompanied by the migration, and then after migration, there is a formation of carbocation. Now the once again the leaving group which is already left comes in attached to the carbonium ion, forming this intermediate. Now upon formation of the ketonic group and successive after a couple of steps, you will get the product what was really formed. So that is how we analyze the mechanism or propose the mechanism by taking consideration the product that is formed and already comparing with the Waverley reaction. Thank you.